Chapter 1.3 is fractions. So before we get into fractions, I just want to mention what the set of natural numbers are because we'll be referring to those throughout the section. So the set of natural numbers, these are counting numbers. So they're just the positive integers. So natural numbers are just 1, 2, 3, 4, 5, 6, 7, and so on. Okay, so jumping into fractions now. I'm sure most of us know about fractions, but a fraction is just a number that represents a part out of a whole. And the part is the numerator and the whole is the denominator. So for example, if we have this fraction right here, 2 over 5, the 2 is the numerator and the 5 is the denominator. So you can read this just how I read it, 2 over 5, or you can write it as 2/5, or read it as 2/5, or 2 divided by 5. So for the next thing we have mixed numbers. So a mixed number is going to be the sum of a natural number and a fraction, but it's going to be expressed without the addition sign. So for example here we have 3 and 4/5. 3 and 4/5 is the same thing as 3 plus 4/5. But we just don't write it with that addition sign. And then you can read it just how I read it. 3 and 4 over 5, or 4/5. Then for the last thing here, we have improper fractions. So an improper fraction is just going to be a fraction where the numerator is greater than the denominator. So there's nothing wrong with these. That just happens to be the name for them. We just call them improper fractions. So if the numerator is smaller than the denominator, that would be called a proper fraction. So let's convert between mixed number and improper fraction. So it's relatively simple to convert. What we have to do is going from a mixed number to an improper fraction, we're going to multiply the denominator of the fraction by the natural number out front and then add it to the numerator. And then we're going to place that result over the original denominator and then we're done. So for example, if we have 3 and 4/5, so 3 and 4/5, what we're going to do is we're going to multiply a denominator by the natural number out front. So 5 times 3, we're going to add it to the numerator, place it over the original denominator. So that's going to be 15 plus 4 all over 5, which is 19 over 5. So 3 and 4/5 is the same thing as 19 over 5, or 19/5. For the next one, 2 and 3/4. So we're going to do the same thing here. We're going to multiply that denominator by the whole number out front, add it to the original numerator, place it over that denominator. So we have 4 times 2, which is 8. 8 plus 3 over 4, so we get 11 over 4. So 2 and 3/4 is the same as 11/4. And then lastly here we have -5 and 5/8. So a little bit different because we have this negative. So we're going to do this the same way, except just put the negative out front and it's just going to kind of come along for the ride here. So it's going to be 8 times 5 plus 5 all over 8. So just keep that negative out front and pretend like it's not on that whole number. So it's going to be 8 times 5 is 40, plus 5 is 45. So we get -45 over 8. So -5 and 5/8 is the same thing as -45 over 8. Okay, and then for the next thing here, so now we're going to go from an improper fraction to a mixed number. So when we are going from an improper fraction to a mixed number, since a fraction just represents division, we're just going to actually divide the improper fraction, and then we're going to record the quotient. So remember, the quotient is the answer that we get for division. We're going to record the quotient and the remainder. And then we're going to write the mixed number using this following form, where it's the quotient and the remainder over the original denominator. Okay, so when we are, let's do these examples here. So it's going to be 42 over 5. So we're going to divide it. So 42 over 5. So if you remember, for dividing, we have to think how many times does 5 go into 42? That goes in 8 times. Then you multiply 8 times 5 is 40. Subtract, we get 2. That's going to, we have to stop right there because 2 is less than the 5. So this is the remainder. And this 8 up here is the quotient. 42 is the dividend and 5 is the divisor. Okay, so this is going to give us an answer of the quotient and the remainder over the original denominator. So 42 over 5 is the same thing as 8 and 2/5. Okay, and then for the next one, we have 36 over 7. So once again, let's just divide it. So 36 over 7. 7 goes into 36 5 times. Multiply 5 times a 7. We get 35. We subtract and get 1. That's going to be the remainder here. So 36 over 7 is 5 and 1/7. And for C, we have negative 52 over 4. So I'm going to divide them, and I'm going to ignore the negative. So we think, how many times does 4 go into 5? It goes in once. Multiply, subtract 5 minus 4, we get 1. Bring down the 2. 4 goes into 12 3 times. It actually goes in evenly. So that's going to give us a remainder of 0. So negative 52 over 4 is going to be negative, whoops, now we can't forget the negative this time. So it's going to be negative 13 and 0 over 4. So that's obviously pretty silly. 0 over 4 is just 0. So our answer here is just negative 13, which should make sense because 52 divided by 4 is just 13. Okay, so for the next thing here, we have factors of a number. So factors of a natural number are going to be other natural numbers that multiply to that number. So when we say that we're going to be factoring a number, that means we're going to rewrite it as a product of 2 or more other natural numbers. Okay, so let's do some examples here. So let's list all the factors of the following. So list all the factors of 21. So we can have 1 times 21 equals 21. 3 times 7 equals 21. So the factors, these are things that multiply to 21. So those are all of the factors of 21. They're going to be 1, 3, 7, and 21. And for the next one, for 30, so thinking about some numbers that multiply to 30, once again, we have 1 times 30. We can do 2 times 15. We can do 3 times 10 and 5 times 6. So hopefully you can kind of see how I'm doing this in a nice little order on the side, so I don't miss a factor. So these are all the factors of 30. So we have 1, 2, 3, 5, 6, 10, 15, and 30. Okay, and then for the next one, for 16, we can have 1 times 16, 2 times 8, or 4 times 4. So the factors of 16 are 1, 2, 4, and 16. So you don't have to write the 4 twice. Obviously, just write it once. And for D here, for 13, factors of 13, we can have 1 times 13. And that's actually it. The only factors of 13 are just 1 and itself, which actually means it's a prime number, which we'll discuss right now. So prime numbers, just like we saw with 13, they're going to be natural numbers greater than 1. So 1 is not a prime number. So it's a natural number greater than 1 that has only itself and 1 as factors. So examples of prime numbers here, we have 2, 3, 5, 7, 11, 13, 17, 19, and so on. So they're prime numbers because, for example, 2, the only factors of 2 are 2 and 1. The only factors of 3 are 3 and 1, and so on. So 2 is the only even prime number. And conversely, for composite numbers are natural numbers greater than 1 that are just not prime numbers. So 1 is neither prime nor composite. So examples of composite numbers are just going to be something like 4, 6, 8, 9, 10, 12, 14, 15, and so on. So for example, we can rewrite 4 as 2 times 2. We can rewrite 6 as 3 times 2. We can rewrite 8 as 4 times 2. Could rewrite 15 as 5 times 3. So these are all composite numbers because they are not prime numbers. We can rewrite them when we factor them as something other than 1 in itself. So for the next thing, we're going to be kind of using that concept here for composite numbers for prime factorization. So prime factorization, every composite number can be expressed as the product of prime numbers. So when we do this, when we express a composite number as the product of prime numbers, this is called the prime factorization of that number. So for example, let's say we have the number 45. 45 is actually the same as 3 times 3 times 5. And since 3, 3, and 5 are all prime numbers, this is the prime factorization of 45. We expressed it as a product of its prime factors. So the way that we can do this, we can start by selecting 2 factors from the original number. If one or both of the factors are not prime numbers, we continue to factor each composite number until they're all prime numbers. And we're going to write our final answer as a product of the prime numbers. So let's do some examples. So let's find the prime factorization of 100. So the way I'm going to write this is kind of like a little tree. So 2 factors of 100 are 2 and 50. 2 times 50. 2 is prime, so I'm going to circle it saying that that branch is done. 2 factors of 50 can be 2 and 25. 2 is prime. And then 25, 5, and 5. So the prime factorization of 100 is 2 times 2 times 5 times 5. Okay, the next one for 36. 36, we can have 2 times 18. 2 is prime. And then for 18, we can have 2 times 9. And then for 9, 3 and 3. So the prime factorization of 36 is going to be 2 times 2 times 3 times 3. Once again, just going over to the ones that we circled. And if you want to double check, you can just multiply those numbers together, make sure that you get 36. Last one here for 94. So it gets a little bit more challenging when the numbers are larger because you have to think of numbers that multiply to that number, some factors of it. 94 is even, so I know that 2 goes into it. So 2 times, I believe it's 47 equals 94. So 2 is a prime. Then you're thinking about 47. 47 is actually also a prime number. So 94 is equal to 2 times 47. So there's actually an infinite amount of prime numbers. So just because the number is large doesn't necessarily mean that it's composite. Okay, so for the next thing, so we're going to be using this factoring idea to help us reduce fractions. So simplifying or reducing means the same thing for fractions. So fractions can be simplified by factoring the numerator and denominator separately, and then we'll be canceling common factors. So a fraction is simplified when the numerator and denominator have no common factors other than 1. And the way that we can think about this, which I'm sure most of us think about this, is by like dividing off common factors. So dividing off common factors. I'll bring that back up again in a few examples here. I'll do it the technical way first. So let's reduce each fraction to its lowest terms. So for the first one, we have 4 over 6, 4 sixths. So we can factor 4 as 2 times 2. And we can factor 6 as 2 times 3. We can cancel common factors because 2 divided by 2 equals 1 over 1. So we're just left with that 2 over 3. So 4 over 6 equals 2 over 3, and then now it's simplified. Okay, and then for the next one, we have 6 over 14. So we can rewrite 6 as 2 times 3. We can rewrite 14 as 2 times 7. 2 over 2 equals 1, so they cancel, and we're left with 3 over 7. So 6 over 14 simplifies to 3 over 7. For the next one, for 15 over 75. So we could factor 15 as 3 times 5. I'm going to leave it as 15. And the reason I'm doing that is putting a little forethought into it. We can rewrite 75 as 5 times 15. So just knowing that 15 goes into 75 just allows us to cancel those 15s off. So we're left with a 1 in the numerator. So we're left with 1 over 5. Okay, for the next one, for D, 11 over 33. So I'm going to think about these ones as dividing off the common factors. So 11 over 33, we could factor 33 as 3 times 11. Or we can say, let's divide the numerator by 11, divide the denominator by 11. We get 1 in the numerator and 3 in the denominator. So either way, however you want to think about it, they're both technically the same thing. And for the last one here, negative 60 over 10. Hopefully this one's pretty obvious. But let's divide the numerator by 10 and divide the denominator by 10. We're going to be left with negative 6 over 1. And then we're going to write that as just negative 6. Okay, so that is reducing fractions. So now let's get into multiplying, dividing, and adding and subtracting fractions. So we'll start with multiplying because it's actually the easiest one. So in multiplying fractions, we multiply numerators together and we multiply denominators together. So if we have something like A over B times C over D, we would multiply numerators and say that's A times C over B times D when you multiply denominators also. And then just keep in mind that a positive times a positive is a positive, negative times a positive is a negative, and then a negative times a negative is a positive. And also note that if we have negative of a negative number, that just makes it positive. Okay, so let's do several examples here. Excuse me. So, for example, let's multiply these and write them in the lowest terms if possible. So the first one, we have 3/7 times 2/5. So just remember, even though I've used it, the notation for multiplication, typically we don't write the little times symbol with the X. We can write the dot, or if we have 2 parentheses next to each other, that also means multiplication. So 3 over 7 times 2/5. So we're just going to multiply right across, and it's going to be 3 times 2 in the numerator, which is 6. 7 times 5 in the denominator, which is 35. And we're done. 6 over 35. Can't be simplified. For the next one, we have 5 times 7/12. So for this one, we have to use the fact that 5 is the same thing as 5 over 1. So it's 5 over 1 times 7 over 12. So we're going to multiply. 5 times 7 is 35. 1 times 12 is 12. Can't be simplified, so we are done. And I'm going to leave it as an improper fraction. Next one, we have negative 2/3 times 9/4. So for this one, what I'm going to actually do here, so it's negative times a positive, so we know our answer is going to be negative. What I'm going to do here is I'm going to rewrite the 9 as 3 times 3. So instead of 2 times 9 in the numerator, it's 2 times 3 times 3. And then in the denominator, instead of 3 times 4, I'm going to rewrite the 4 as 2 times 2. So the only reason I did that is because now you can cancel off common factors, 2 over 2, and also we have a 3 over 3. So we're left with negative 3 over 2. Okay, so you could have multiplied straight across right away and gotten 18 over 12, but then you'd have to simplify it and get negative 3 over 2. So if you recognize that you can factor and simplify before you multiply, it might be a little bit easier sometimes. Okay, so we have two mixed numbers for the next ones. We have 3 2/3 times 1 1/4. What we have to do for these, we have to convert to an improper fraction first. So you have to do this for multiplying or dividing mixed numbers. Technically, when we're adding and subtracting them, we don't have to do it, but you should do it anyway. Just when in doubt, just always convert mixed numbers to improper fractions. So 3 2/3 as an improper fraction is going to be 11 over 3. 3 times 3 plus 2 is 11. And then for 1 1/4, that's going to be 5/4. Okay, so we have 11/3 times 5/4. So I'm going to recognize here that no common factors are going to be canceling off here. So I'm going to multiply straight across. 11 times 5 is 55. 3 times 4 is 12. And then we're done. And then once again, I'm just going to leave it as an improper fraction. Okay, let's do a couple more here to make sure we're good, because obviously this concept's pretty important. So we have 4/11 times 2/3. Once again, I'm going to recognize no common factors. They're going to end up canceling. So multiply straight across. 4 times 2 is 8. 11 times 3, 33. And next, 6 times 3/5. So I'm going to rewrite 6 as 6 over 1, just as a visual aid for us. You don't have to do that if you know what to do. So it's going to be, once again, recognize common factors are not going to cancel off. 6 times 3 is 18. 1 times 5 is 5. So 18 over 5. And for G, we have a negative times a negative here. We know our answers are going to be positive, so I'm going to completely ignore those now. So for the numerator, it's going to be 3 times 1, and the denominator is going to be 7 times 3. So instead of multiplying them, I just rewrote it into one fraction, just so we can see that those 3's are going to cancel. And we're left with 1 over 7. And then for H, for the last one here, we have two mixed numbers, so converting these to improper fractions once again. 3 2/5 is going to be 17 over 5. And then 1 1/2 is going to be 3 over 2. So 17 is a prime number, so I can already tell that nothing is going to end up canceling. So multiply straight across. 17 times 3 is 51. And 5 times 2 is 10. So we get 51 over 10. Okay, so that's multiplying fractions. Dividing fractions is pretty simple as well. It's going to be almost the same steps, except we have to do one more thing compared to multiplying. So we're going to actually change division to multiplication. And before we do that, we have to bring up what the definition of a reciprocal is. So the reciprocal, which is also called the multiplicative inverse, but the reciprocal is the more commonly used name for it. So the reciprocal of a fraction, if the fraction is a over b, the reciprocal is going to be b over a. So what we're doing is pretty much just flip-flopping the numerator and denominator here. Reciprocals always have a product of 1 also. Okay, so the way that we're going to be doing this is the quotient, so that just means when we're dividing, the quotient of two fractions is the same as the first fraction multiplied by the reciprocal of the second fraction. So we're going to keep the first fraction the same, change division to multiplication, and flip or reciprocate the second fraction. So the commonly used phrase for this is keep, change, flip. So we keep the first one the same, change to multiplication, and reciprocate or flip the second fraction. I don't even like using the word flip, but obviously it's easier to say flip than reciprocate. Okay, so let's do some examples here. So divide and simplify if possible. So we have 2/3 divided by 7/15. So keep, change, flip. Keep the first one the same. Change the multiplication. Reciprocate the second one. So we have 2/3 times 15/7. So now we multiply just like we did previously. So the way I'm going to do this, we have 15 in the numerator and then a factor of 3 in the denominator. 15/3 is 5. So I'm going to it's not cross multiplying, it's cross canceling essentially. 15/3. So we're left with a 1 down here. And then we're left with a 5 up here because 15/3 is 5/1. So now it's going to be 2 times 5, which is 10, and 1 times 7, which is 7. So a couple different ways to think about how to cancel these. I like canceling before you multiply, because then if you cancel before, then you don't have to cancel afterwards. And then you're working with smaller numbers, so it's a little bit easier. Okay, next one, we have 3/4 divided by -5. So first, I'm going to rewrite -5 as -5/1. And I also just kind of put the negative with the 5 in the numerator. You could have put it in the denominator. You could have put it out front. It really doesn't matter. Okay, so keep, change, flip. Keep the first one the same. Change the multiplication. So we're multiplying by -1/5. And it looks like nothing's going to cancel here, so let's multiply. So -3/20. Okay, let's do a couple more. So we have 4 3/4 divided by 1 1/2. So once again, let's change this to an improper fraction for both of them. So 3 3/4 becomes 19/4. So 4 times 4 is 16, plus the 3 is 19. Divided by 1 1/2 is 3/2. Okay, so keep, change, flip. Keep the first one the same. Change the multiplication and reciprocate or flip the second one. So 19/4 times 2/3. Okay, so 19 is a prime number, so I don't have to think about any factors for that. This 2 in the numerator and 4 in the denominator have a common factor of 2. So they're going to cancel. We're going to have a 2 left in the denominator and just the 1 in the numerator. So it's going to be 19 times 1, which is 19. 2 times 3, which is 6. So 19/6. Okay, and for the next one, do 2 more. We have 5/4 divided by 3/8. So keep, change, flip. Keep the first one the same. Change the multiplication. Reciprocate the second one. So we will have some common factors canceling. We have 8 divided by 4. 8 divided by 4 is the same thing as 2/1. So 5 times 2 is 10. 1 times 3 is 3. So this equals 10/3. And for the last one here, for E, -2/3 divided by -3. So I'm going to write this as -2/3 divided by -3/1. So negative divided by a negative, this is going to give us a positive. So same rules apply to division that did for multiplication with the negatives. So I'm going to rewrite this and I'm going to get rid of the negatives. So it's 2/3 divided by 3/1. And keep, change, flip. So 2/3 times 1/3. So it's going to be 2 times 1 is 2. 3 times 3 is 9. So 2/9. Okay, so that's multiplying and dividing. Multiplying is usually the easiest. Dividing is the second easiest. Adding and subtracting is usually the most annoying. So to add and subtract fractions, they first must have a common denominator. So that's why these ones are a little bit harder, because we might have to adjust one or both of the fractions. So once they do have common denominators, we can just simply add or subtract the numerators and place it over that common denominator. So for example, if we have like a over c plus b over c, they have common denominators of c, so it's just going to be adding the numerators over that original denominator. Okay, so for if they don't have common denominators, we have to find it. So we would have to find the least common denominator, which we denote as using LCD. So finding the least common denominator between two fractions, the least common denominator is going to be the least common multiple between the denominators. So we're going to find the smallest multiple that both denominators have in common, and then we're going to have to adjust them, and we're going to rewrite the fractions as equivalent fractions so they have the least common denominator. So we're going to have to multiply the numerator and denominator by the same value to get that common denominator. So let's do some examples. So let's do 3/11 plus 4/11. So these already have the same denominator of 11, so we can just add the numerators. So 3 plus the 4 in the numerator over that common denominator, we get 7 over 11. So pretty simple. And obviously simplify if possible. Just as always, just always try to simplify it. So the next one, we have 5 over 12 minus 11 over 12. So they have common denominators of 12. So subtract the numerators. So 5 minus 11 over 12. 5 minus 11 is negative 6. So negative 6 over 12, a factor of 6 is going to cancel. We're going to be left with negative 1/2. And for C, so we have mixed numbers again. So technically, we don't always have to switch it for adding and subtracting, but there is an issue with how we could come across some issues with doing it that way. So let's just convert this to an improper fraction, and we don't have to worry about it. So 5 1/4 as an improper fraction is going to be 5 times 4 is 20, so 21, add the 1 over the 4. And then 2 3/4 is going to be 11/4. So 21/4 minus 11/4, common denominators, subtract 21 minus 11 is 10. So we get 10/4. There's going to be a common factor of 2 that cancels, so we're going to be left with 5 over 2. Okay, and the next one for D. So now they do not have same denominators. We have 1/5 plus 3/4. So now what we have to do is we have to find the LCD between those denominators here. So it's going to be, if you need to write them out, I'll do it just this once. So we're going to have the multiples of 4, and then we're going to find the multiples of 5, and then we're going to see which is the smallest number they have in common. So the multiples of 4 are going to be 4, 8, 12, 16, 20, 24, and so on. So they are just essentially keep on adding 4. So 4 times 1, 4 times 2, 4 times 3, and so on. Multiples of 5. Just make sure you don't forget that the number itself is a multiple of itself. So multiples of 5, we have 5, 10, 15, 20, 25, and so on. Okay, so the number that they have in common here, the smallest one that they have in common, is going to be 20. So that means the LCD equals 20. So we have to think, how can we rewrite both of these numbers so they have a denominator of 20? So we do this by multiplying. So we have, in order for 5 to get to 20, we have to multiply it by 4. But we also have to multiply the numerator by 4 because we can't change it. 4 over 4 is just equal to 1. So to get this other denominator to 20, we have to multiply by 5. So once again, do it to the numerator as well, so we're not changing anything. Okay, so for the first one, 4 over 4 times 1/5 is going to be 4 over 20. For the second one, 3/4 times 5 over 5 is going to be 15 over 20. So now they have common denominator, so we add the numerators, 4 plus 15, we get 19 over 20. Okay, so let's do the next one. So once again, we do not have common denominators. So 3/4 minus 6 over 1. So this is the same thing as 3/4. I think I just said it actually. 3/4 minus 6 over 1. So the least common multiple of 4 and 1 is simply going to be that 4. So that means we have to multiply this one, second one, by 4 over 4. So we didn't even have to adjust the first one. So that's going to be 3/4 minus 24 over 4. 3 minus 24 is negative 21. So we get negative 21 over 4. And for this last one here, 7 over 20 minus 4 over 15. So it's going to be, we need to find the least common multiple of 20 and 15. So you could list out the multiples. The multiples of 20 would be 20, 40, 60, 80, 100, and so on. The multiples of 15 are going to be 15, 30, 45, 60. So that means the LCD is going to be 60. It was the smallest multiple that they had in common. Okay, so we need to rewrite both of these fractions so that they have 60 as the denominator. So in order to, so we have to multiply numerator and denominator by something. So in order to get from 20 to 60 by multiplying, we have to multiply by 3. So multiply by 3 over 3. And then for 15, we would have to multiply by 4 to get to 60. So we have to multiply by 4 over 4. So for that first fraction, 3 over 3 times 7 over 20, 7 over 20, it's going to be 3 times 7 is 21. 3 times 20 is 60, which is what we wanted. For the second one, 4 over 15 times 4 over 4, that's going to be 16 over 60. Okay, so this is going to give us 21 minus 16, which is 5. So it's going to be 5 over 60. So they're actually going to have a common factor of 5 that cancel, which would be, we're left with 1 in the numerator, and then 60 over 5 is going to be 12. So if we cancel those common factors, we end up with 1/12. Okay, so for the last thing here, we have some word problems. So for this first example, so to repair a plumbing leak, a coupling 1/2 inch long is glued to a piece of plastic pipe that is 2 9/16 inches long. We want to know how long is the combined length when they're glued together. So combined length, that tells us that we are adding, right? So what we have to do is we have to add 1/2 plus 2 9/16. Okay, so for adding this, we need to convert to a improper fraction for 2 9/16. So it's going to be 1/2 plus, so 2 9/16, 16 times 2 is 32. 32 plus 9 is 41. So it's going to be 41 over 16. And we need the least common denominator. So the least common denominator here is going to be 16. The multiples of 2 are all even numbers, 2, 4, 6, 8, 10, 12, 14, 16. Multiples of 16 are 16, 32, 48, and so on. So the one that they have in common, that's the smallest, is 16. So in order to get from 2 to 16, we need to multiply by 8 over 8. So the first fraction becomes 8 over 16, and then plus that 41 over 16. So 8 plus 41 is 49, so this is 49 over 16. And I'm just going to leave this once again as a improper fraction. You can convert to a mixed number if you want. And this is going to be in inches, so that's going to be the total length. Okay, and then for the last one here, we have a carpenter is cutting a rectangular piece of wood. It's 4 feet wide by 10 2/3 feet long, and they're cutting it into 4 equal strips as shown below. So we wanted to determine the dimension of each strip. So we want to determine the dimension of this little block, just one of these blocks. All of them are going to be the same. So obviously the width of that is going to be 4. The length is not going to be 10 2/3. It's going to be 1/4 of the 10 2/3. So that means it's going to be 10 2/3 divided by 4. So before I even do anything, I'm going to convert 10 2/3 to a improper fraction. So that's going to be 3 times 10 is 30, plus 2 is 32, so 32 over 3. Okay, so now we need to find out what 1/4 of that is, which means we are dividing it by 4. So 32 over 3 divided by 4, I'm going to write it like this. So this is going to be 32 over 3 times, so remember 4 is the same as 4 over 1. So keep change flip. We're going to be multiplying by 1/4. So instead of dividing by 4, we're multiplying by 1/4 here. Okay, so what I'm going to do, I'm going to cancel off some common factors right now. 32 over 4. 32 actually goes in, or 4 goes into 32 8 times. So 32 divided by 4 is 8. So we're left with 8 over 3 times 1 over 1. So that's just equal to 8 over 3. Okay, so for the dimensions, the dimension of each strip is going to be obviously it's going to be 4 feet by something. It's going to be 4 feet by the 8/3 that we just found. So the 8/3 feet. I'll actually convert 8/3 to a mixed number here. So as a mixed number, 8/3 is going to be, so this is when you would just divide it. It would be 2 2/3. 3 times 2 is 6, plus 2 is 8, 8 over 3. Okay. So it's 4 feet by 2 2/3 feet. And that's our answer. Okay, so that is it for section 1.3.